Welcome to Course 20 of the MaxLife Commercial Academy. I'm Ryan Solberg, real estate broker with MaxLife Realty LLC, and today we're diving into one of the most exciting and fastest growing institutional asset classes in all of commercial real estate, data centers and AI campuses. Whether you're an investor looking to diversify into infrastructure-backed assets or a broker trying to understand what your institutional clients are chasing, this course is going to give you a serious edge. We'll cover the four major data center types, how to read tier ratings, why power is everything, how to underwrite a deal, and what the AI demand surge means for returns through 2035. Let's get into it. So why are data centers suddenly the asset class every institutional investor is talking about? Let's start with what one actually is. A data center is a specialized real estate asset designed to house, power, and cool the computing infrastructure that runs the entire digital economy, everything from cloud storage to AI model training. And here's the mental shift I want you to make. Every ChatGPT query, every Netflix stream, every cloud backup you've ever made lives in a physical building that somebody owns. The internet isn't floating in the air, it lives somewhere, and that somewhere is real estate. Now look at the demand picture. Global data center capacity is projected to double by 2030, driven by AI, cloud, and streaming. Vacancy in the top tier US market sits below 2%. That's tighter than any other commercial asset class you can name. Office can only dream of those numbers. That scarcity is why institutional capital from Blackstone, KKR, and sovereign wealth funds has absolutely flooded into the sector since 2022. But here's the constraint that defines the whole opportunity, and we'll come back to it again and again in this course. It's not land that limits new supply anymore, it's power. Getting megawatts to a site is now the binding bottleneck, and the reason serious investors love this asset is the cash flow profile. Many of these deals are structured as net leases with investment-grade tenants, which makes the income stream predictable and bond-like, much closer to a NNN industrial deal than to a speculative tech play. That combination of explosive demand, severe supply constraints, and credit-backed leases is exactly what makes data centers so compelling right now. Not all data center investments are the same animal, so let's break down the four structures you'll encounter, plus the tier ratings that cut across all of them. Start with the powered shell, because this is the most accessible structure for a private investor. The landlord delivers the building, the power, and the cooling infrastructure, and the tenant builds out all the IT equipment at their own cost. That means the lowest landlord responsibility, long NNN leases, and cap rates in the 5.5 to 7% range. If you understand a net lease industrial deal, you can understand a powered shell. Next is colocation, where multiple tenants rent rack space, cages, or suites inside one facility. You get stronger diversification across tenants, but a lot more operational complexity, and those trade around 5 to 6.5. Then there's hyperscale, purpose built for a single cloud giant like Amazon, Microsoft, or Google. That's the lowest cap rate of the bunch, 4 to 5.5, because you're buying the highest credit quality on earth. And finally, data center REITs like Equinix and Digital Realty let you buy a slice of a national portfolio with full liquidity, trading at 3.5 to 5%. Now layer the tier ratings on top. Tier I and I2 give you basic redundancy, 90.6 to 99.7% uptime, lower construction cost, and they suit edge and regional use cases at wider 6.5 to 8 caps. Tier 3 and IV deliver N plus 1 to 2N redundancy on every system, 99.98% uptime and better. That's mission-critical infrastructure for enterprise and hyperscale tenants, and it compresses cap rates accordingly. The pattern to remember: more redundancy and stronger credit always mean a tighter cap rate. If there is one concept I want you to walk away from this lesson knowing, it is this. In data center real estate, power is the product. Everything else, the building, the fiber, the cooling, exists to support the delivery of reliable, high-density electrical power to computing equipment. Let me break down the 4 specs you need to know cold before you ever underwrite a data center deal. First is critical load, measured in megawatts. This is the actual power available to IT equipment, and it is the primary driver of rent. A facility delivering 10 megawatts at $100 per kilowatt per month is a $1 million per month gross revenue asset. Simple math, enormous scale. Second is power usage effectiveness, or PUE. This is total facility power divided by IT load. A PUE of 1.2 means for every dollar of power going to servers, you are using 20 cents on cooling and overhead. That is best in class. A PUE of 2.0 means you are wasting as much power cooling the building as you are running the computers. Tenants care deeply about this, especially those with ESG commitments. Third, and this is the big one in today's market, is utility substation access. In places like Northern Virginia, Phoenix, and Chicago, data center developers are sitting on entitled land that they simply cannot power because the utility queue is 4 to 7 years out. Facilities with existing substation access and available capacity are worth multiples of what a vacant parcel would bring. And fourth is backup power, generators, UPS systems, and fuel storage. Tier 3 and IV assets require N plus 1 or 2N redundancy, meaning if any single system fails, operations continue without interruption. Understanding who is responsible for this capital, landlord or tenant, is critical to modeling your return. Let's talk about how these assets are actually priced relative to the commercial real estate you already know, because the structure you choose drives both your cap rate and your risk profile. Here's a formula to anchor everything. Monthly rent equals critical load in kilowatts times the dollar per kilowatt per month rate. In data centers, you're effectively leasing power, and that equation is the backbone of every pricing conversation. Now compare the two ends of the structure spectrum. On the left, the powered shell NNN. The tenant builds out all the IT infrastructure at their own cost, and you as the landlord just deliver the base building, power, and cooling. Leases run 10 to 20 years with fixed bumps of 2 to 3%, and cap rates land at 5.5 to 7%, depending on tenant credit and power density. The landlord risk here is low. It really is close to a net lease industrial deal, which is exactly why it's the easiest structure for a private investor to underwrite and finance. On the right side, you've got colocation and hyperscale. Here the landlord operates the facility and sells capacity by the rack, the cage, or the suite. You get multiple revenue streams, but a lot more operational complexity. A hyperscale deal is a single credit-rated tenant, and cap rates can compress all the way down to 4% because you're buying Amazon or Microsoft as your tenant. Colocation gives you diversified tenants with more upside in the 5 to 6.5 range. Both of these command significant premiums over traditional industrial or office, and both are dominated by institutional buyers, which means as a private investor, you're competing at the margin. That's precisely why I steer most individual clients toward the powered shell structure first. Florida does not make anyone's shortlist when they think Tier 1 data center markets. That conversation starts in Ashburn, Phoenix, Chicago, and Dallas. But Florida is increasingly on institutional radar as a Tier 2 market with a specific set of advantages worth understanding. Start with Miami. The reason Miami matters is fiber connectivity to Latin America and the Caribbean. When a financial institution in Sao Paulo or a media company in Mexico City needs low latency connectivity to North America, Miami is the landing point for subsea cables. That creates durable colocation demand that is not going anywhere. Tampa Bay is growing fast. FPL and TECO are both expanding industrial power infrastructure. Land costs are a fraction of Northern Virginia, and the enterprise user base, finance, healthcare, defense contractors, is building out rapidly. Orlando is interesting because of the military and simulation cluster around UCF and the defense corridor. These users need data processing that cannot go to a public cloud. They need controlled on-premise or co-location facilities. Now for the headwinds. Hurricane exposure is real. Any Florida data center you evaluate should be Tier 3 at minimum with wind design to Category 4 standards, and that adds meaningful construction costs. Utility interconnection delays are also real. Plan for 24 to 48 months in most Metro Florida markets. But here is the offset. Florida has a statutory sales tax exemption on data center equipment and electricity that is worth millions per year in operating cost savings for large facilities. That incentive is one of the reasons institutional developers are looking harder at Florida than they were 5 years ago. Underwriting a data center deal sounds intimidating, and the institutional models run to hundreds of tabs, but the core framework is actually 4 clean steps, and I want to walk you through each one so you can apply it on your next deal. Step 1 is establishing critical load. You need to know exactly how many megawatts of utility power are delivered to the site, and then you need to haircut that for PUE overhead. If the facility draws 12 megawatts from the grid and has a PUE of 1.2, you have 10 megawatts of critical load available to IT equipment. That 10 megawatts times your lease rate per kilowatt per month is your top line revenue. Everything flows from that number. Step 2 is modeling power cost. In a triple net powered shell, the tenant pays for power directly. So your P&L looks a lot like a NNN industrial deal. But in a colocation or gross lease structure, power cost is your largest operating expense, and you need to model both the current utility rate and a reasonable escalation assumption. A 3% annual rate increase on a 10 megawatt facility is a meaningful number over a 10-year hold. Step 3 is lease credit and structure. This is where data center underwriting most resembles NNN analysis. Pull the tenant credit rating, confirm the lease term, understand the annual rent bumps, and read the termination clause carefully. A 15-year lease with a BBB rated hyperscaler and 2.58% annual bumps is a very different asset than a 5-year deal with an early stage colocation operator. Step 4 is applying your cap rate and running sensitivity. Divide stabilized NOI by your target cap rate. Then build a simple sensitivity table. Cap rates across the top from 4.5 to 7.0%. Power lease rates down the side. That table tells you exactly what you can pay for the asset and still hit your return. This is the framework. Learn it, drill it, and you will be able to evaluate any powered shell opportunity that comes across your desk. Now let's zoom out and talk about the force driving all of this, the AI demand surge, and what it means for this asset class through 2035. The build-out of generative AI infrastructure is creating a capital expenditure cycle unlike anything the data center sector has ever seen, and the real estate that houses it is in critically short supply. Let me give you the numbers because they're staggering. Microsoft, Google, Amazon, and Meta collectively announced over $300 billion in data center capex in 2024 alone. That's a single year. And AI is not like the workloads that came before it. AI training clusters require 10 to 100 times the power density of traditional enterprise computing. That's why so much of the existing inventory simply can't serve AI demand. It was never built for that kind of load. CBRE projects the US needs a 50% increase in data center capacity by 2030 just to keep up. Because of power constraints, vacancy is expected to stay below 3% in the top markets through at least 2028. And here's the part that matters most for you as an investor. New construction lead times run 3 to 5 years, so supply physically cannot respond quickly. That means existing facilities with power already in place command an enormous premium. The fastest growing subsegment is edge data centers, smaller facilities closer to end users, as AI inference moves out to the network edge. The strategic takeaway is this: investors who move early in emerging Tier 2 markets like Florida can capture development and lease up upside before institutional capital compresses those cap rates. AI does not run in some abstract cloud. It runs in a building, and the opportunity is to own the building. If you want to explore how to position for this, give us a call at 321 586 2121. That is a wrap on Course 20, Data Centers and AI Campus Real Estate. You now understand the four major data center types, how Tier 1 through Tier 4 ratings translate into cap rate differences, why power infrastructure is the single most important spec you will evaluate, and how to run a powered shell underwrite from start to finish. You also have a framework for thinking about Florida data center markets and a clear view of what the AI demand surge means for this asset class over the next decade. I hope this course helps you approach data center opportunities with real confidence. If you have questions, want to talk through a deal, or just want to connect, reach out to us directly at MaxLife Commercial. The number is 321 586 2121. And you can find the full academy and all our resources at maxlifedevelopment.com/academy. I'm Ryan Solberg, broker with MaxLife Realty LLC, and I'll see you in Course 21, Tax Strategy and 1031 Exchanges.